Okay, moving on. Gwen Schoenfeld. She studied neuroscience in the University of Heidelberg, and after that she moved to Zurich to do her PhD. She's fascinated by brain, and in particular how it works when we are learning something new. So I guess tonight we're going to make our brains work as she's going to tell us something new. So prepare to listen her talk. Great minds think alike. Gwen Schoenfeld.
Ladies and gentlemen, welcome to our flight from Bern to Cheltenham. Please remain silent, as our pilot and co-pilot are participating in a scientific experiment. So let's enter the cockpit. Until now, the flight has been very relaxed, and our two aviators are relaxed as well. But then, from one moment to the other, an alarm goes off, lights start flashing, and half of the instruments go black. They are dead. After a brief moment of panic, our two aviators make a decision. It is going to be tough, but they know how to land the plane safely. But to do so, they will have to work together as one single unit. Outside the flight simulator, there's a team of neuroscientists glued to their computer screens. They have been recording the brain activity of our two aviators during the whole flight. And from the moment on, pilot and co-pilot started cooperating. Something extraordinary happened to their brains. They synchronized with a slowly oscillating rhythm. Inter-brain synchronization can be seen when two people are having a meaningful social interaction. And human life is all about social interactions. Hunting down the mammoths in prehistoric times, or juggling modern work and family life. We are just not made to face these challenges alone. We need the help of others, and they need us. And indeed, when two brains, and therefore two people, synchronize, we start acting more socially. We trust each other more. We are willing to help another more readily. So it seems that our brains are just designed to connect. But are they really? The human brain is incredibly complex, and all we can currently do to understand it better is to record its activity pattern and relate them to events that happen around us. The sudden alarm inside the flight simulator, or the brain activity of your fellow pilot. These signals might look similar to your own brain activity, but it does not mean that they are caused by each other. Pilot and co-pilot are seeing and hearing the same things. Both are terrified. Both try to work out a way how to avert a disastrous plane crash. These thoughts alone might already be enough to make their brain activities look alike. But now, on top of all that, there seems to be a social link binding together their brains and turning them into an unbeatable team. But until we know for sure how inter-brain synchronization works, there's still a very long but very exciting scientific journey ahead of us. And so far, I hope you enjoyed your flight.
Thank you very much, Gwen. Questions, please. Patricia.
Can you say some more how brains synchronize? What's the entry points, a part of this alarm?
I have to say, this is just an hypothesis. Most of cognitive science is working with hypotheses. I don't want to make the claim that our brains, without our interference, do connect with each other. There are a lot of signals around us, environmental signals, the alarm, anything you might be thinking, which can cause similar activity patterns. And now those studies, and there are some of them, claim that there are certain regions which makes us feel more empathic towards each other. And if two people are having some sort of a connection, those regions show similar activity patterns in an oscillating rhythm. But how that really works is difficult because it's human interaction, and human interaction are messy.
Susan?
Do you work with experiments in your research? I mean, do you bring people together and observe them in the laboratory, or how does it look like, your work?
Like me personally, I'm not working with human neuroscience, But such an experiment that I just described, this was really a flight simulator. There were two trained pilots who worked together on a daily basis, put inside the flight simulator. They're both wearing EEG caps, and they are just doing their thing, totally forgetting that they are participating in an experiment, so it's as naturalistic as possible. Of course, it's important for neuroscience to control for all that, because they are talking to each other and so on. So there are also some experiments where you just take the person out of the natural situation and put them into a brain scanner, for example, where you just really have the person lying and just thinking about talking to somebody else. There's a lot of variety what you can do. And someday, when we combine all that, we will figure out how we interact.
Okay, thank you very much, Gwen.
Thank you.